Hi guys, so today we're going to talk about solubility curves. So a solubility curve tells us how much solute can be dissolved in a solvent at a specific temperature. So remember, solute is what we are dissolving. Solvent is what we're using to do the dissolving. To make our solution. So here we see how much solute can be dissolved in a specific amount of solvent at specific temperatures. So why specific temperatures? Well, think about that. Hot tea compared to iced tea, right? We can put more sugar into hot tea than we can into iced tea because remember, those water molecules, when they're hot, have more energy, so they are moving more and they're spaced further apart. So more sugar can get in between those water molecules that are heated up than water molecules that are cold. So the water molecules in cold tea or iced tea are moving more slowly, they're more compact, they're closer together, so less sugar can fit in between those molecules. All right, so here we are looking at a solubility curve, and each one of these lines is talking about a different solute. So here we have sodium nitrate, calcium chloride, lead nitrate. Oh, I'm sorry. Here we have sodium chloride, calcium chloride, potassium chloride. So we have all these different things, solutes that we're looking at. And what it's showing us is where the line is where we would be at saturation. That means that the solvent is holding as much of that solute that it possibly can at that temperature. And so we go down here in the bottom and we see here we have 10 degrees Celsius. And as we go up, let's go up here to sodium nitrate. As we go up at 10 degrees Celsius, water can hold 80, right? Because we go 80, so we make this connection between 10 degrees Celsius and 80. And we see that for every 80 grams of sodium nitrate in 100 grams or 100 milliliters of water. So as we warm up the water, we see that we can put more sodium nitrate into that water. See, that line is increasing. And if we look, we see that we only have one thing here that decreases. We have cesium sulfate. As cesium sulfate, the water is warmed up, its solubility actually decreases. We can put less in there. And we see sodium chloride has very little change. That would be like table salt there. So let's take a look here at some practice problems. So our first problem, how much sodium nitrate can be dissolved in 100 grams of water at 10 degrees Celsius? So that was the problem I just used in the example. You start down here at 10 degrees Celsius and you go up until you meet the line of the salt that we're talking about. And then you come over and we see that it is 80 grams is how much we can dissolve. Let's look at our second one. Which substance is least soluble at 60 degrees Celsius? So least is going to be that we can put the least amount of substance into our water. So that's going to be the first line, right, that we hit. So we go to 60 degrees here because that's what it's asking for. And the first line that we hit is that cesium sulfate. So our answer here is Ce2SO4 and a 3. Our third problem, if 60 grams of potassium chromate are dissolved in 100 grams of water at 90 degrees Celsius, is the resulting solution supersaturated, saturated, or unsaturated? Okay, so here we have potassium chromate. We're at 90 degrees Celsius. So I'm going to go over here to 90 degrees Celsius. And we also want 60 grams of potassium chromate. So we're going to go up from 90 here, and then we're going to go over and we're going to see where 60 grams of substance right here meets the temperature of 90 degrees. And we're talking about potassium chromate. So we see that where those two meet is below the saturation line. So that means that this is unsaturated because it is below the saturation line. Okay, now if we were at the same temperature and we added 20 grams of potassium chromate, right, we would be up here. If we added 20 more grams, we would be at 80. And when we bring that line across here and down, now we're up here, we're above the saturation line. So what would this be? This would be super saturated because it is above the saturation line. Let's look at another example and some different scenarios. So let's say we have 50-degree water. And we add 100 grams of sodium nitrate. So let's take a look at that situation first. So we're at 50 degrees Celsius. So we bring it up and we have 100 grams. And so we want to see where those two things meet. So here's 100 grams and 50 degrees Celsius, and we see where they meet. Now we're looking at sodium nitrate. So that's this guy right here. So all those other lines, we don't care about them right now. So we're going to look at this line right here. Our dot, where 100 grams and 50 degrees Celsius meet, is under that line. So this is an unsaturated solution. What are two things that we could do to make this a saturated solution? Well, the first one is we could add more solute. We could add more sodium nitrate. So if we want to make this super saturated, right, if we want to make it saturated, then we want to take it to this line right there, right? We're keeping the same temperature. And so we want to increase it to about 112 grams. So to make it saturated, we want to add 12 more grams of NaNO3. If we wanted to make it super saturated, then it would be anything up here, we would add greater than 12 grams. But the other thing that we can do is we can cool our solution, right? We can bring our line this way. Let's say we don't have more sodium nitrate. Well, we could cool the solution. And so we want to keep it at 100 grams, and we want to meet that line right there this time. And we're going to bring it down. And so to make a saturated solution of sodium nitrate that has 100 grams, we want to cool this to about 35 degrees. So saturation would also be to cool this guy down to 35 degrees Celsius. And again, if we wanted to be super saturated, we could cool it even further without changing the amount. And so making it any colder than 35 degrees Celsius is going to make it super saturated. And as we said before, also for supersaturation, we can add anything over 12 grams of our solute. So there we go. So that's how we use a solubility chart.